Welcome friends to my YouTube channel Sommo Physics. For few days some of my students told me to make videos based on classical mechanics also that I teach in first semester honors. Okay, so from today I will start classical mechanics. So before I start, I want to tell you that if you have not subscribed my channel, kindly subscribe my channel and share it to your friends, neighbors, relatives. Okay, so let's start. So today I will going to discuss about few basic things about the first chapter of my portion in classical mechanics, that is about the central force. Okay, now first question that arises, what is central force? So all of you know that a central force is one that is always directed away or towards a fixed center, and magnitude of this force entirely depends upon the distance between the interacting bodies. That is, simply we can say this force is only a function of r. Say F vector equals to F into r cap. We can write it in this form: F vector, this is equal to magnitude of F multiplied by r cap, that is r vector. So this force is entirely depends upon the distance between the interacting bodies. What are the examples? The common examples are gravitational force, electrostatic force. These are the examples of central force. Okay, now second question that arises, what are non-central forces? Now simply the non-central forces are those the magnitude of which not only depends upon the distance between the interacting bodies but also on other factors or parameters, say like spin, or you can say relative orientations. These, that is, non-central forces depends upon these factors, that is spin, relative orientations, etc. So familiar example we all know, that strong nuclear forces and weak nuclear forces, these are the examples of non-central forces. So this is the first. Now the second question that arises, that what are the basic features of central force? What are the basic features of central force? So first feature is that this force is conservative, and work done by this force around a closed path is always zero. Okay, conservative force means simply the work done totally depends upon the initial and final position. Okay, then we say that the force is conservative, that is the work done only depends upon the initial and final position. So this force is conservative and work done by this force around a closed path is always zero. And conservative, in case of a conservative force field, we all know that mm, force is derivable from a scalar potential. Okay, so this is the first property. Second property, that we can say that this force can be expressed as the gradient of a scalar potential. That is, we can write if this is equal to minus grad v. We can prove it in next class, that this force can be expressed as the gradient of a scalar potential, that is F equals to minus del v or grad v. Number 3, in case of a central force field, a particle must lie in a plane. This is one of the features. The particle must lie in a plane. Another property is that angular momentum of the particle in a central force field remains conserved. Okay. And the last one is that total energy of a particle in a central force field, this also remains conserved. So what are the features? First of all, this force is conservative. That is, the work done by this force around a closed path is always zero. Second is that this force can be expressed as the gradient of some scalar potential, say F equals to minus grad V or F equals to minus grad phi, whatever you can say. In case of a central force field, a particle must lie in a plane. Angular momentum of a particle remains constant in central force field, and we can say that total energy of a particle, total mechanical energy of a particle in a central force field remains constant. So these are the basic features. We can prove this in our next class. Okay. Now, one thing must have to know, obviously we must have to know that here we tell about few forces: gravitational, electrostatic, strong nuclear and weak nuclear. We have discussed these four type of forces, and these are the four forces that are exist in nature. Briefly I shall discuss about it. First of all, gravitational force. What is that? We all know that gravitational force is the weakest force in nature, and this force is always attractive. These are the basic features. Gravitational force is the weakest force in nature, and this force is always attractive, and it is only applicable to heavier bodies. Okay, only applicable to heavier bodies. And second of all is electrostatic force. This is also a central force, but this force can be attractive or repulsive, both, depending upon the sign of charges. Okay, if the charges are of same sign, then they are repulsive, and the charges are of opposite sign, they are attractive. And this force is of infinite range force. Okay, and both are gravitational and electrostatic, both are inverse square forces. That is, F is always proportional to 1 by r square. Okay. Third one is that strong nuclear force. We already know, all of you know that in a nucleus there are protons inside the nucleus, and they repel each other. So we cannot explain the stability of the nucleus unless we assume that the nucleons inside the nucleus are held together by a strong attractive force. Okay, this force binds the nucleons inside the nucleus. So this is the strong nuclear force. That is, this force explains the stability of the nucleus. Okay, and we know there are three type of interactions: pp, pn, nn, proton to proton, proton to neutron, and neutron to neutron, and the strength of three interactions are same. This is most important point, that the strength of three interactions are same. Okay, and the last one is that weak nuclear force. This is a short range force, and this is a very short range force, and the familiar example you all know, that beta decay, where the decay products are leptons. Okay, so in beta decay this type of force exists. So in today's video I give brief discussion on some basics of central force. In my next video I will going to prove the properties that I tell today. Okay, so if you don't subscribe my channel, then kindly subscribe my channel to get latest updated videos. Okay, thank you.